Hello everyone, welcome to GChem classes. So today we are going to solve for a NEET chemistry question. Like previously I have teach you that mole concept, and based on that we will have some PYQs. So it has asked in JEE main and then NEET. So we have some collection of questions. Let me see. One by one I will discuss those questions. So first one I am taking. So which one of the following contains the highest number of oxygen atom, right? So first they have given, I just write 1 mole, first option is 1 mole of uh, aluminium sulfate, right? 1 mole of aluminium sulfate. So it will be Al2SO4 tries. Option B, it has given 3 moles of ferrous sulfate, right? 3 moles of ferrous sulfate. So 3 moles of ferrous sulfate. Option C, it has given 3 moles of hydrogen peroxide. So 3 moles of hydrogen peroxide. Option B, it has given 2 moles of potassium permanganate. Okay, 2 moles of potassium permanganate. Option E, it has given 1 mole of potassium dichromate. Okay, 1 mole of potassium dichromate. So now the question is which one of the following contains the highest number of oxygen atoms. So how you are going to calculate for the highest oxygen atom number? So you have to search that the maximum number of moles wherever it is present, that will be the highest number of oxygen, right? So suppose 1 mole of aluminum sulfate, it's having 4 into 3, 12 moles of oxygen. Okay, in this how many are there? 3 moles of ferrous sulfate. So 4 and 3, how much it is coming? 12 moles of oxygen. In this how many moles of oxygen are present? 2 into 3, 6 moles of oxygen. Here how many moles of oxygen is present? 4 into 2, so 8 moles of oxygen. Here you see how many moles of oxygen are there. So 1 mole of oxygen, but number of oxygen is 7. So total how many moles? 7 moles of oxygen. So in this your correct answer will be A and B. I don't know how it has put in which of the following contains the highest number of oxygen atom, but these two is having, like, for this 1 mole is 12 moles of, like 1 mole of aluminum sulfate is having contains 12 moles of oxygen. Here also 3 moles of ferrous sulfate contains 12 moles of oxygen, right? So the answer will be A and B because these two is having same, right? 12 and 12, and these are the highest number. So for this question, this either of these answer will be there. So I think maybe after examination, what has happened, they have considered both A and B, right? So next question we will take it. Let's see next question. Next question I am taking. See in screen the number of nitrogen atoms in 681 gram of. Okay, they are asking number of nitrogen atom, right? Okay, the formula first I'll write down. C7H5 N3O6 N3O6. Okay, so what is the amount? It has given 681 gram of this compound, and now they are asking the number of nitrogen atom in this compound, right? So they have given is X into 10 to the power 21. They have given the number of nitrogen. Number of nitrogen they have given X into 10 to the power 21. Okay, this X you have to find it out. It's you have to find out the moles, right? How many moles are there, that you have to find it out. So how you are going to find out the moles? The molecular formula of this compound you should know. Whether they have given molecular weight of this compound. No, you have to find it out for molecular weight. This is the given weight, right? So molecular weight, how you are going to calculate? So 7 into 12 plus, here it will be 5 into 1, correct? Plus here it will be here it will be 3 into how much it is, how much it will come for nitrogen? It will be 14, then plus 6 into 16. This you have to solve it. Okay, so how much it is coming? Okay, okay, I'm having like how much it is coming up. I know 227 it will come. Okay, just you calculate it. If it is the number is then getting difference, then we can discuss it again once again. Correct. So it is 227. Now what we have to do it? Just find out the moles. Okay, number of moles of this compound. The given weight is 681 divided by the molecular weight of this compound 227. So how much it is coming? Just divide it, you'll get it around, I think 3 point something it should come. Okay, 3 point something it should come because 3 times it is going, so it will be 3 moles. Now you see, this compound is 3 moles, right? In this much amount, this compound is 3 mole. So now each mole of this compound containing 3 mole of nitrogen. Okay, it will be like each mole of the given compound from C7H5N3O6 contains how many moles? 3 moles. 3 moles, right? So 3 moles of this compound, how many moles of nitrogen will be contained? It will be 3 into 3. So total 9 moles of nitrogen will contain. Now what you have to do it? 9 into your Avogadro number you have to do it, right? So here I will do it. So now number of nitrogen, it will be Avogadro number 6.022 into 10 to the power 23. This number is belongs for 1 mole of nitrogen, right? Now we have 9 mole. So 9 into 6 it will come around 54 something it is coming. So it will be 5481 into 10 to the power 21. So now this is the value of x, right? This is the value of x. So this is a NET type question. So wherever the x is there, that place you put it 5481, right? 5481 into 10 to the power 21. This factor will be there. So this one they have given. So only you have to put the value for x, right? So x is 5481, correct? Okay, I'll wrap the board. By the time you see the question, next question, you can see it is in screen. Okay, and try to solve by yourself. Okay, okay, try to solve by yourself. Next we will take another topics like after mole concept, atomic structure will come. We'll discuss next class. We will discuss atomic structure. Correct. So next question, it is very nice question actually. See, it's given that CNG is an important, don't read the history. Basically what we need, when 100 gram of CNG is mixed with 208 gram of oxygen, what we will do it? CNG, so methane we can write it. So methane, and they are doing reaction with oxygen. So what will happen? CO2 plus H2O. Correct? Now in this reaction, we know that to balance the reaction we have to take 2 mole of oxygen, 1 mole of carbon dioxide is correct, so 4, here 2, so 2 mole of water will liberate. Okay, we know that 1 mole of methane will to complete combustion it will give 1 mole of carbon dioxide, right? So likewise what they have given, when 100 gram of CNG means they are telling that 100 gram of methane, so just convert it to the mole. Okay, how many moles it will be there? 100. 100 is given weight divided by what is the molecular weight? It is 16. So this is the moles, and it is reacting with mixed with 208 gram of oxygen. Okay, 208 gram of oxygen. So this will be 208 divided by what is the molecular weight for this? For this type of reaction it will be like 32. So 16 into 2, so 32, right? So 208 divided by 32. So how much it is coming, that we have to see it, correct? Whatever moles it will come, then again we have to divide by 2 because 2 mole it has taken. No, this will become the moles of oxygen, right? So how much it is coming? If we are solving 6.25, this one will come 6.5, 6.5, okay, 18, okay, 6.5 it will come, right? Now what we have to calculate, it leads to the formation of CO2 and H2 and produce large quantity of heat. During this combustion, then the amount of carbon dioxide produced in gram is, so amount of carbon dioxide they want, right? So here what is happening, 1 mole of CH4 Okay, methane is giving 1 mole of carbon dioxide, but here what is happening, 1 mole, and one more thing, 1 mole of methane is reacting with 2 mole of oxygen, but here you can see it, 6.25 mole of methane is required, almost double, right? So double means it will be 12.5 mole it's required, but the given mole is 6.5 only, so here it will act as limiting reagent, LR, right? This will act as a limiting reagent. So now you have to calculate like this, 2 mole of oxygen is giving 1 mole, because now this won't play because it is in excess, right? But the oxygen is a limiting reagent here. So now what you have to do it, with the 2 mole it is giving 1 mole, right? So for 6.5 mole, how much mole of carbon dioxide it will produce? Likewise you have to calculate it. So simply you just do it, 2 mole of oxygen is giving 1 mole of carbon dioxide. So 1 mole of oxygen will give 1/2 mole of carbon dioxide. Now you just write it down, 6.5 mole of oxygen will give 1/2 into 6.5 mole of, what is that? Carbon dioxide. So no need to solve this one, just take this much mole of carbon dioxide will produce. Now weight of carbon dioxide, okay, weight of carbon dioxide, like how much carbon dioxide is getting produced, that we will do it. How it will be like number of moles of carbon dioxide into molecular weight of carbon dioxide, right? So 1/2 into 6.5 into 44, right? This formula from where we got it? Let's see. This formula is getting moles, number of moles equal to given weight divided by molecular weight, correct? Given weight divided by molecular weight. Okay. So now this given weight, if you want to calculate, so just do it cross multiplication. Okay, so weight equal to, it will be moles into molecular weight. That thing only I have taken. This is the mole and this is the molecular weight. Now this will be 22. Now 22 into 6.5, how much it is coming? 22 into 6.5, it will come around 143 gram, because I have already calculated 143 gram, correct? 143 gram of this. So you see the next question by the time I'll rub the board. Okay, it is like 0.2 gram of an organic compound was subjected to estimation of nitrogen by Dumas method, okay, in which volume of nitrogen evolved at STP was found to be 22.4 ml. So how much nitrogen it has found? 22.4 ml, right? And the given organic compound mass is how much? 0.2 gram, right? Organic compound mass is 0.2 gram. In that we have found 22.4 ml of nitrogen, okay? The percentage of nitrogen in the compound is, right? The percentage of nitrogen you have to calculate it. So first of all, you have to just convert it to the mole. So mole of nitrogen, how you are going to convert it? Moles of nitrogen, it will be like given ml is 22.4 ml, okay, divided by we know the STP volume of one mole of gas will have volume of 22.4 liter in STP, right? So 22.4 liter equal to 2 to 4, this much ml it will be, like just see 1 2 3 is extra, so this one if we are going to cancel it, it will be 1000, so this will cancel it out. So now it will be 1/1000 moles, right? 1/1000 moles, we got it. So now next step, what we are going to do it, it's like weight of nitrogen we have to find out, right? So weight of nitrogen, how you are going to find it out? Weight of nitrogen. So for weight of nitrogen, it will be like moles and molecular weight. So what is the mole? 1/1000 is your moles of nitrogen. Now molecular weight of nitrogen, it will be 14 into 2, so 28. So now it will be 28 divided by 1000, okay? So now how much it is coming? 0.028, right? 0.028 gram, correct? So now we will see, now that they are asking in the questions percentage of nitrogen in organic compound, right? So how you are going to calculate this percentage of nitrogen in organic compound? It will be like this amount, how much it is there? 0.028 divided by, what is the mass of organic compound? 0.2 into 100, right? So how much it is coming? This will go, so 1, 2 and this 3. So here 100 will be there down. This 100 will cancel out. 2, 14. So it will be 14%, right? So your correct answer will be 14%. So it's just NET type of question. So you have to write 14%. Let's see the next question. Okay, next question is, just see the next question. Okay, so in that next question, this 120 gram of an organic compound that contains only carbon and hydrogen. So they are not saying that which organic compound it is there, but they are saying that carbon and hydrogen it contains, right? Gives 330 grams of CO2 and 270 grams of water. So with this only we have to calculate the mass of organic compound. How much this organic compound mass? It is 120 gram. What else it has given? 120 gram the mass it has given. Mass of carbon dioxide it has given 330 gram. So carbon dioxide mass 330 gram, and then they have given 270 gram of water. So water they have given 270 gram. Okay, water they have given 270 gram. Now they are asking that complete combustion, the percentage of carbon and hydrogen respectively. Okay, so carbon and hydrogen respectively in your organic compound, that 120 gram is there, no, in that they are asking carbon and hydrogen what will be the composition, right? So that percentage composition you have to find it out. So for that, what you have to do it, you know that mole to mole reaction is happening, no? So just you have to find out how much mole of carbon dioxide is there and how much mole of water is there. Based on that, we will calculate the starting materials mole. Correct? So here moles of carbon dioxide, we'll see. It will be given weight divided by its molecular weight. So 330 divided by 44, it is the moles of carbon dioxide. Correct? Now we have to find it out weight of carbon, right? We know that 1 mole of carbon dioxide contains 1 carbon, right? So this many moles of carbon dioxide will contain how many like what will be the weight of carbon? Okay, so weight of carbon equal to moles is 330 divided by 44 into the molecular weight of carbon, right? How much molecular weight of carbon is 12. So we are going to solve it. The value of this one will get you the weight of carbon. So how you are going to solve it? 2, it will be 22, and then here it will be 6, then again 11, this is 3, so 11, 3, 30, so 30 into 3, 90 gram. So overall this reaction we have 90 gram of carbon, right? So now percentage of carbon you have to calculate, percentage of carbon. So now see, this carbon dioxide contains 90 gram of carbon, and whatever carbon it contains, that is directly coming from your starting material, right? So the starting material, whatever 120 gram of organic compound is there, in that we have 90 gram of carbon, right? So likewise you have to play the logic, and then you have to get the answer, right? So percentage of carbon, so what is the weight of carbon? It is 90, and what is the molecular, like total weight of your organic compound? It is 120, right? So now solve it. How much it is coming? 3, 4. So 3 by 4, it will be into 100, right? Into 100. So 25. So 25 into 3, 75%. Remaining, we no need to calculate percentage of hydrogen. Directly we can say percentage of hydrogen will be 100 minus 75, means it will be 25%. So now your option, you see the option, it is like respectively carbon and hydrogen, right? So carbon will be 75% and hydrogen will be 25%. So your option D will be your correct answer, right? Option D will be your correct answer. Now the next question we will have, this question has asked in NEET 2021, right? An organic compound contains 78%. Just I'll rub the board, you just see the question. Okay, an organic compound contains 78% by weight carbon and remaining percentage of hydrogen, right? So carbon percentage of carbon is 78%, correct? And percentage of hydrogen, they are telling that remaining percentage is hydrogen, right? So 78, 100 minus 78 means how much it is coming? 22% of hydrogen it contains, right? The next line, what it says, the right option for the empirical formula of this compound is. So they want empirical formula, right? Only empirical formula they want. Okay, empirical formula. Already we have solved this kind of questions. Yes, last class, right? Last NEET class we have solved this one. So just what you have to do for this kind of questions, you have to take 100 gram is the this carbon and hydrogen containing compound. Whatever the carbon and hydrogen containing compound they are saying, that should be 100 gram, and then based on that 100 gram we have to find it out. So let's suppose the total mass of the organic compound is 100 gram. In that we can say mass of or weight of carbon, it will be 78 gram, and mass of hydrogen, it will be 22 gram. Now find it out the mole. So moles of carbon, it will be 78 divided by 12, we know, right? So 78 divided by 12, how much it is coming? 78 divided by 12, it will come around 6 and then 6.5. Okay, so 6.5 moles it came. Now for hydrogen, how much moles it is coming? Moles of hydrogen equal to, it will be like given weight is 22 and the weight is 1, so it will be 22 moles. Okay, now for empirical formula, what we are doing, just we are converting it to the simplest whole number, right? Simplest whole number, and that will be the empirical formula. So now how you are going to do it? So just write it down. Carbon is to hydrogen. Here carbon, you just write it down 6.5 is to hydrogen. How much it is there? 22. So how you are going to do it? Let's see. Just divide it by 6.5. Here also you divide by 6.5. Here it will be 1 is to how much? Here it will be like 6 4s are 24. So 4 it won't be there. 6 3s are 18 and 5 3s are 18. So how much it is coming? 19.5 20. So maybe it is approximately 3, right? So 1 is to 3. So 1 carbon and 3 hydrogen. So this will be the empirical formula, right? CH3. So this will be here. This will be the empirical formula. So correct option will be option number D, right? Correct option is option number D. So now next question we will see it. You see the question by the time I rub the board. Okay, so what they are asking, compound A contains 8.7% of hydrogen. Just I'll write it down along with that. Compound A contains 8.7% of hydrogen. So 8.7% of hydrogen. Okay, then next 74% carbon. 74% carbon. Then 17.3% nitrogen. 17.3% nitrogen. Okay, and then the molecular formula of the compound is, okay, they are asking molecular formula of the compound, but they have not given the molecular weight, right? So molecular weight, if they are not giving, it is very difficult to calculate the molecular formula. What we can do it, we can just calculate it empirical formula, because empirical formula easily we can calculate it with this percentage, because empirical formula is the simplest whole number, right? So that we can calculate it. If they have given the molecular weight, then only we can calculate the molecular formula. Otherwise it is very difficult, because we have to calculate that n factor, right? My previous class, you can see that we have calculated the factor number, that n. So n was 2, that's why we have multiplied it, okay, with the empirical formula, and then we got the final molecular formula. But here they have not given the molecular weight. Maybe the questions, maybe whatever the question is there, we have to solve accordingly, right? So we can't put in our head that, okay, molecular formula they have asked, so we have to give molecular formula itself. They have not given molecular weight, so the empirical formula only we can frame it here. Let's see how it is. So 17 for it is total is 100%. No. So what we have to do it, let the mass is 100 gram. Okay. So 100 gram mass. In that 100 gram, we can directly write hydrogen. How much gram it is there? 8.7 gram is there, and we know that hydrogen molecular weight is 1. So how much mole it is coming? Directly we will calculate it. Okay, 8.7 mole. Now for carbon, how much weight out of 100? 74 gram. We know that molecular weight is 12 gram. So how much mole it is coming? 12. Okay. 7 times it won't go, 6 times it will go. Okay. 72 and then 20. So 1 and then 8. So it will be so 6.1 and then again 8. So let's write down 7. Okay, it will be 6 and again it is going further. So better it will be 6.17 mole. And then we have nitrogen. So for nitrogen, how much it has given? 17.3, correct? And we know that its molecular weight is 14. So now how much it will come? 14. Again it will be 1 point. Okay, 1 point, and then it will be like 333. So 14, 28. Around 2 it will come. 1.2. Okay, 1.2. 1.23 you take it mole. Okay. So mole we have already calculated. So empirical formula. So for empirical formula, what we can write it? Carbon is to hydrogen is to nitrogen. Just write it down. So how much mole of carbon it is there? 6.17 is to hydrogen. How much it is there? 8.7 is to nitrogen. How much it is there? 1.23. So what we have to do it? Everything we have to divide by 1.23, right? Just divide it 1.23, 1.23, 1.23. How much it is coming? This will be 1. So nitrogen 1. This will be like 12. It will be like 84, right? So 84 means 7 times. 12 7s are 84. So it will be around 7 times. Approximately you have to take because whole number you need. Okay, fraction it won't help you out. So now here it will be like 1. I think 12. 5 times it will be 60, right? 12 5 just 60, so it will be like 5. So 5 is to 7 is to 1, so we can write it C5 H7 N1. So this will be the empirical formula, right? We have this option here, C5 H7 N. Okay, we have option number C, right? Option number C will be the correct answer here, right? But molecular formula, if they want, they have to give that molecular weight. Then only with this empirical formula weight, we will just take it the molecular formula weight divided by like what is the molecular formula weight they have given. With that weight, we will just divide this empirical